Lesson 1. Solids, Liquids, and Gases. Reading Guide. Key Concepts. Essential Questions. How do particles move in solids, liquids, and gases? How are the forces between particles different in solids, liquids, and gases? Vocabulary. Solid. Liquid. Viscosity. Surface tension. Gas. Vapor. Describing matter. Take a closer look at the photo on the previous page. Do you see matter? The three most common forms, or states, of matter on Earth are solids, liquids, and gases. The giant bubble contains air, which is a mixture of gases. The ocean water and the soap mixture used to make the bubble are liquids. The sand, sign, and walkways are a few of the solids in the photo. There is a fourth state of matter, plasma, that is not shown in this photo. Plasma is high-energy matter consisting of positively and negatively charged particles. Plasma is the most common state of matter in space. It also is in lightning flashes, fluorescent lighting, and stars, such as the sun. There are many ways to describe matter. You can describe the state, the color, the texture, and the odor of matter using your senses. You also can describe matter using measurements, such as mass, volume, and density. Mass is the amount of matter in an object. The units for mass are often grams, g, or kilograms, kg. Volume is the amount of space that a sample of matter occupies. The units for liquid volume are usually liters, L, or milliliters, ml. The units for solid volume are usually cubic centimeters, cm raised 3, or cubic meters, m raised 3. Density is the mass per unit volume of a substance. The units are usually grams per cubic centimeters or grams per milliliters. Density of a given substance remains constant, regardless of the size of the sample. Particles in motion. Have you ever wondered what makes something a solid, a liquid, or a gas? Two main factors that determine the state of matter are particle motion and particle forces. Particles, such as atoms, ions, or molecules, moving in different ways, make up all matter. The particles that make up some matter are close together and vibrate back and forth. In other types of matter, the particles are farther apart, move freely, and can spread out. Regardless of how close particles are to each other, they all move random motion, movement in all directions and at different speeds. However, particles will move in straight lines until they collide with something. Collisions usually change the speed and direction of the particles' movements. Forces between particles. Recall that atoms that make up matter contain positively charged protons and negatively charged electrons. There is a force of attractions between these oppositely charged particles, as shown in Figure 1. You just read that the particles that make up matter move at all speeds and in all directions. If the motion of particles slows, the particles move closer together. This is because the attraction between them pulls them toward each other. Strong attractive forces hold particles close together. As the motion of particles increases, particles move farther apart. The attractive forces between particles get weaker. The spaces between them increase, and the particles can slip past one another. As the motion of particles continues to increase, they move even farther apart. Eventually, the distance between particles is so great that there is little or no attractive forces between the particles. The particles move randomly and spread out. As you continue to read, you will learn how particle motion and particle forces determine whether matter is a solid, a liquid, or a gas. Solids. If you had to describe a solid, what would you say? You might say, a solid is matter that has a definite shape and a definite volume. For example, if the skateboard in Figure 2 moves from one location to another, the shape and volume of it do not change. Particles in a solid. Why doesn't a solid change its shape and volume? Notice in Figure 2 how the particles in a solid are close together. The particles are very close to their neighboring particles. That's because the attractive forces between the particles are strong and hold them close together. The strong attractive forces and slow motion of the particles keep them tightly held in their positions. The particles simply vibrate back and forth in place. This arrangement gives solids a definite shape and volume. Key concept check. Describe the movement of particles in a solid and the forces between them. Types of solids. All solids are not the same. For example, a diamond and a piece of charcoal don't look alike. However, they are both solids made of only carbon atoms. A diamond and a lump of charcoal both contain particles that strongly attract each other and vibrate in place. What makes them different is the arrangement of their particles. Notice in Figure 3 that the arrangement of particles in a diamond is different from that in charcoal. A diamond is a crystalline solid. It has particles arranged in a specific, repeating order. Charcoal is an amorphous solid. It has particles arranged randomly. Different particle arrangements give these materials different properties. For example, a diamond is a hard material and charcoal is a brittle material. Reading check. What is the difference between crystalline and amorphous solids? Liquids. You have probably seen a waterfall, such as the one in Figure 4. Water is a liquid. A liquid is matter with a definite volume, but no definite shape. Liquids flow and can take the shape of their containers. The container for this water is the riverbed. Particles in a liquid. How can liquids change their shape? The particle motion in the liquid state of a material is faster than the particle motion in the solid state. This increased particle motion causes the particles to move slightly farther apart. As the particles move farther apart, the attractive forces between the particles decrease. The weaker attractive forces allow particles to slip past one another. The weather forces also enable liquids to flow and take the shape of their containers. Viscosity. If you have ever poured or dipped honey, as shown in Figure 5, you have experienced a liquid with a high viscosity. Viscosity is a measurement of a liquid's resistance to flow. Honey has high viscosity, while water has low viscosity. Viscosity is due to particle mass, particle shape, and the strength of the attraction between the particles of a liquid. In general, the stronger the attractive forces between particles, the higher the viscosity. For many liquids, viscosity decreases as the liquid becomes warmer. As a liquid becomes warmer, particles begin to move faster and the attractive forces between them get weaker. This allows particles to more easily slip past one another. The mass and shape of particles that make up a liquid also affect viscosity. Large particles or particles with complex shapes tend to move more slowly and have difficulty slipping past one another. Surface tension. How can the nursery web spider in Figure 6 walk on water? Believe it or not, it is because of the interactions between molecules. The blowout in Figure 6 shows the attractive forces between water molecules. Water molecules below the surface are surrounded on all sides by other water molecules. Therefore, they have attractive forces, or pulls, in all directions. The attraction between similar molecules, such as water molecules, is called cohesion. Water molecules at the surface of a liquid do not have liquid water molecules above them. As a result, they experience a greater downward pull, and the surface particles become tightly stretched like the head of a drum. Molecules at the surface of a liquid have surface tension, the uneven forces acting on the particles on the surface of a liquid. Surface tension allows a spider to walk on water. In general, the stronger the attractive forces between particles, the greater the surface tension of the liquid. Recall the giant bubbles at the beginning of the chapter. The thin water soap film surrounding the bubbles forms because of surface tension between the particles. Key concept check. Describe the movement of particles in a liquid and the forces between them. Gases. Look at the photograph in Figure 7. Where is the gas? A gas is matter that has no definite volume and no definite shape. It is not easy to identify the gas because you cannot see it. However, gas particles are inside and outside the inflatable balls. Air is a mixture of gases, including nitrogen, oxygen, argon, and carbon dioxide. Reading check. What is a gas, and what is another object that contains a gas? Particles in a gas. Why don't gases have definite volumes or definite shapes like solids and liquids? Compare the particles in figures 2, 4, and 7. Notice how the distance between particles differs. As the particles move faster, such as when matter goes from the solid state to the liquid state, the particles move farther apart. When the particles in matter move even faster, such as when matter goes from the liquid state to the gas state, the particles move even farther apart. When the distances between particles changes, the attractive forces between the particles also changes. Forces between particles. As a type of matter goes from the solid state to the liquid state, the distance between the particles increases and the attractive forces between the particles decreases. When the same matter goes from the liquid state to the gas state, the particles are even farther apart and the attractive forces between the particles are weak or absent. As a result, the particles spread out to fill their container. Because gas particles lack attractive forces between particles, they have no definite shape or definite volume. Vapor. Have you ever heard the term vapor? The gas state of a substance that is normally a solid or a liquid at room temperature is called vapor. For example, water is normally a liquid at room temperature. When it is a gas state, such as in air, it is called water vapor. Other substances that can form a vapor are rubbing alcohol, iodine, mercury, and gasoline. Key concept check. How do particles move and interact in a gas?